All right, so we always factor first, look at it. The domain, we're going to look at what we can't have. X cannot be -3, right? Because if I plug -3 in here, -3 plus 3 is 0. So we say that by saying I'm going to do a little thing. We know -3 doesn't work, but I can be anything else. So that's -infinity to -3, -3 to infinity, right? We got to take that out. I don't know if that's better. Maybe that's better. There we go. All right. Are there any holes? No. Why are there no holes? Nothing cancels. Write that down. That helps you remember. Right? It helps you remember why don't I have holes? Nothing cancels. I know it looks like canals, that C ran in, but nothing cancels. Are there any roots? Roots come from the top, right? Whatever makes the top 0. And what makes the top 0? -4 and -2, right? Vertical asymptotes come from the bottom. What makes the bottom 0? -3. And remember that's an x equal because that is referring to a vertical line. Tangent or togetherness. Are any of the factors squared? No. So we have none of that. What about in behavior? Our choices are top heavy, bottom heavy, or balanced. What is this one? Well, let's look. We have x squared up there and x here. So it is top heavy. So we're going to divide to see what our asymptote is. So we're going to, right, there's 1, 6, 8. This is why we had to learn our synthetic and long division. We're going to divide by -3. That comes from the bottom, that negative. And we know we bring that 1 down. Now it's -3 times 1. So 6 is 3. And what did we say about this last number? We ignore it. We don't need that. The whole premise of this is to figure out which way your ends are pointing, and that's irrelevant. So this was squared, so now this is not squared. So it's what? 1x plus 3, and it's y equals. And then what's the y-intercept? You plug 0 in for x. What do you get if you plug 0 in for x? You can just kind of, sometimes I think it's easier to go back to your original instead of the factored part. And if I cover up everything with an x, it's 8/3. All right, let's graph. We have all the details, right? We have all the clues. Now we got to try to put a picture to that. So roots, -4, -2. Asymptote at -3. Well, this is looking pretty weird. This is x equals -3, right? No tangent or togetherness. Y-intercept is at 8/3. How do I graph 8/3? Just 8 divided by 3, right? So a little bigger than 2. Somewhere up there. Now x plus 3, how do we graph that? Well, that's just a line, right? With the y-intercept at 3. So 1, 2, 3. And then it's got a slope of 1. So that's down 1 over 1, down 1 over 1, down 1 over 1. Or up 1 over 1, up 1 over 1. So here's this guy. We knew it was going to be slanted because the top was 1 power greater than the bottom. I'm not really giving you ones to graph this year where the top is 2 bigger or 3 bigger. That would just make a parabolic or a cubic. That's okay. We're going to stick with linear this time. So how are you going to draw this? I have to use all 3 of those dots, right? So I'm just going to use my dots and try to stay close to my lines. This has a dot. You always stay close to your dotted lines, to your asymptotes, and you must use your points. They're not really dots, they're points, but not bad, right? You got that. Everything we graph today is a little bit on the weird side. You have to follow your clues, but that's okay. You'll get good at it. It's easy. If you have your DH Ratey memorized, you're good to go. Or if you made a note sheet and put it in a sheet protector, some of us did that, right? Is that okay? When you go to sketch these, remember you're going to use your points and stay close to your asymptotes. That's all you got to do. Are we good? Okay, we're going to keep going. All right, what's the domain on number 2? Well, what can x not be? X can't be -2, right? So that's going to be -infinity to -2. Right? Any holes? No. Why? Nothing cancels. There, I wrote that one bigger so it doesn't look like canals. Is there a root? Yes, and where do I find those? Top equals 0. So that would be at 3, 0. Are there any vertical asymptotes? Well, we find out by setting bottom equal to 0 and keep writing that. That's what's going to put that in your head so it's good. What would make the bottom equal 0? Okay. Tangent? Yes. And what does tangent mean? It's going to be tangent at 3, 0, right? Because that comes from the top being squared. Is there any togetherness? That comes from the bottom squared. Yes, at x equals -2. So the bottom comes from your asymptote. Top comes from your root. Tangent, notice how top and top go together, bottom and bottom go together. End behavior, is this top heavy, bottom heavy, or balanced? It's balanced. So it's the ratio. So y equals, this has a 1 and a 1 in front of your x's. I like to write the 1 over 1 to remind myself that I looked at the coefficients. Sometimes 1 happens so often you start to think it's 1 instead of that ratio. Y-intercept. Now these are both squared, so they're both going to be what? Positive. And it's going to be what? 9/4. Right? Okay. So does everyone feel comfortable getting your left side information in? The graph might be scary yet, but you can get the left side done. Then graphs are good. So let's follow our clues. The root at 3. Asymptote at -2. Now tangent at 3. What does that tell you about this point? When you touch this, you're going to bounce. You're not going to cross, right? I'm going to write bounce there. Now, x equals -2. They're together. What does that tell you on either side of this asymptote? They're together. That means the arrows are either both going up or they're both going down. They're together. And the y-intercept is at 9/4. How big is that? A little bigger than 2? Okay. End behavior asymptote, y equals 1. What did we say about end behavior asymptotes? Can you ever cross those? Yes. So usually I'll put mine kind of going, but I kind of leave it out in the middle. Remember what it says, end behavior. So in the middle, sometimes you cross that one. Sometimes you don't. You never cross a vertical, never. Okay. What's the only way I'm going to play a little bit. Don't write this down. I'm going to use a pencil so we can erase it. What do you think this looks like? Is it this? Y'all answer yes or no. Do not write this down. Is it this? How do you know that's wrong? What did I do right there? I crossed the x-axis. You can't do that. There's no point there. That's definitely not it. No, no, no. Okay, can you think of any other way I can connect these dots? These points? Could I do this? Now remember, I bounce. Does that work? That works. I bounced like I was supposed to. I crossed the y-axis. I did not touch the x-axis again. And we said they were together. So this arrow is going to go up. Now tell me how you would know beyond the shadow of the doubt that this was not good. If I did this and said, here you go, guys. How do you know that's wrong? There's a big clue I want you to always recognize. What happened right there? Cross the x-axis. Can I cross the x-axis? No. That's why I like to put my points in marker. So if I start to try to cross the x-axis and I don't have a point, I can't go there. And I knew that anyway because it says they're together. So if this arrow goes up, this arrow has to go up. And that makes more sense, right? Now, if I get nervous and I'm like, yeah, I'm not really sure, what's my backup plan? I can plug in points. I can say, well, I don't know. Over here at 1, 2, -3, is it positive or negative? I could plug. But what do you notice about this? The top is squared. So what's the end result of the top always? Positive. The bottom is what? Squared. So what's the bottom? Always. So that means this thing is always positive. So that's another clue that's telling you if it's not 0, it's always up top. Because this is a positive part. And if something comes out negative, it's down here. So there's lots of clues. Now that's a lot to think about. But as we practice saying that, you're going to start to say, oh yeah, I remember that clue. It may take a while, right? Not bad, right? It looks scary, but when you start looking at clues, you know, you're a detective. You follow the evidence. All right. So I'm going to pause this and I'm going to see if you can fill out this part without me. I think you're good. Okay. All right. So let's follow the evidence and see if we can graph this thing. So it says there's a root at 3. 1, 2, 3. It says there's an asymptote at -2. And sometimes I like to write underneath it what that was because it may help me as I look at togetherness. It makes me go to the correct one. You know what I mean? X equals 6. This is x equals 6. Okay. Y-intercept just here. Is that everything we can put on there? Okay. So oh wait, and behavior asymptote is at 0, right? If I have 2 verticals, I don't even put my end behavior in the middle because it's the end behavior. It's guiding your ends. Now, where's our comfort level with at least getting the asymptote and the points on? Are we good with that? It's the branches that are hard, right? That's the scary part. Okay. So let's just look at this. It says I'm tangent at 3. What does that mean to me? We bounce. So this, what is this going to look like? A frown? Could it be this? Now don't write this down. Could it be this? No, it didn't bounce. Could it be this? Yes, very good. And that's what I want you to notice. You had to go through the x-axis. We can't do that. No, no, no. So where is this guy? He's got to be in the bottom. That's the only way that I can hit this guy, bounce there, and come back down. This doesn't have to be, it's not perfectly symmetrical like a parabola. It's a little pointed. And mine looks a little, you know, you don't quite touch it. You just touch at that point and come back. We bounce. We're tangent. Tangent means I touch and skim off. Now, what happens at x equals -2? They're together, right? So if this arrow's going down, this arrow's going down. They're together. That's all because that -2 was squared. Now, are they together over here? They're not. So if this arrow's going down, where's the arrow on this side going? Up. See how if you understand, this is not bad. What does the child who refuses to memorize your rules have to do? Well, he's got to make a table of values and start plugging a whole bunch of numbers in. And if you get scared and you're like, it just doesn't look right, this one's down, that one's up. You know, it could be a little person waving at you, right? It's a guy driving down the street. He's got his arm on the car and he's waving. See? I know, I see faces. That's not really part of the graph. Don't put that on. Okay. Well, where's our comfort level? Not too bad, right? All right. We're going to try a couple more things. What if instead of giving you a picture and an equation, what if I gave you the clues? Could you go back and write the equation? All the clues are done. We're going to try and write the equation from that. It's actually very, very easy. So, right, we know it's a fraction because it's a rational function. Rational means function. From this domain, what do you know is true about the bottom? Well, let's just look. The vertical asymptotes are 3 and -3. So what factors are in the bottom? That's got to be x minus 3, x plus 3, right? Now, it's got roots at 1 and -1. Where'd we get those? Top. So that's got to be what? X minus 1, x plus 1. Now, the end behavior, let's see if this is done. The end behavior is y equals 1. That means my powers should be the same in both places, are they? This is x squared, this is x squared. Whoops. X squared over x squared equals 1. That's true. That's true. There's no tangent or togetherness, so that means there's nothing squared. No holes, so I shouldn't have any matching factors in the top and the bottom. That's good. Check. Nothing's the same. Domain, yeah, the 3's are there. Now the y-intercept is 1/9. I need to go in and check and see if I plug zeros in, if it's 1/9. The only thing I could possibly have to do would be to add a coefficient to make it right. If you plug 0 in for x, do you get 1/9? You do. We're done. Very, very easy once you have the clues. Yes, sir. Oh, no, leave it factored. We don't want to put those together unless someone makes us do it because they're not useful together, right? We see all of our information apart. So you're good like that. We don't have to go on. All right, let's try this one. So f of x equals, all right, no holes. That means I don't have any matching factors in top and bottom. There's a root at 1 that came from the top. So what's in the top? That's a 1, so it's what? X minus 1. Now here's my vertical asymptotes. Those go to the bottom. So that's what? X minus 4, x plus 2, right? True? Okay, is there any tangent or togetherness? It says none. What does that tell me about my factors? Nothing squared. End behavior is y equals 0. That means bottom heavy. And this is x over x times x, which is x squared. Is that bottom heavy? Bottom heavy, check. The y-intercept is supposed to be 1/8. So now if you plug 0 in, you get -1 over -4 times 2, which equals 1/8. Check, it's correct. Not bad, right? Once you have the clues, writing the equation is easy. Plotting all the points is easy. The scary part comes from drawing your branches, and you'll get over that. All right. Now, instead of giving you clues, I gave you a picture, and I want the equation. All righty, here we go. Can you do it? You can do this. I would always put my asymptotes in so I can clearly see. It's much easier to do this if you sketch your asymptotes. Okay, and where's the top one? This looks like it's getting close. I could see that this is going through, right? I see this, and I see this. All right. Let's do the top. What factor is in the top? Oh, wait, there's another one right there. Okay, what factor is in the top? X plus 3. What other one? X minus 2. Not bad, right? What goes in the bottom? And? Yes, that is a 2. Right? This is x equals -2. This is x equals 3. So the 3 gave us this. The -2 gave us that. Not bad, right? Now the last thing you want to check, you can see that this is balanced. This is x squared over x squared, so it's balanced. So that's 1 over 1, so 1 is good. Now plug zeros in and make sure that your y-intercept matches up. Sometimes you may have to add a number like a 1 or well, not a 1, but like a 2 in front. You could have to adjust with a number out here to fix the y-intercept. Does it work as it is? That would be what? -6 over -6, which is 1. And that's 1. Okay. We'll do 7 together, and I'll let you try 8. So sketch in. What is that? X equals 2? -2. And I have a point there. It's okay to write on your graph, right? Now there's a hole at 3. Okay. Let's see what we get. What do we get from the top? Where do you see an x-intercept? Okay, so that's x minus 2. What do we get from the bottom? Where do you see a vertical asymptote? X plus 2, right? Now, there's a hole at 3. So what does that mean? Cancels. So that's what? X minus 3 over x minus 3. This is, we don't need to know what the y value is of that hole. It's just a smidgen above the x-axis. That's not important to our equation. We would find that if we cancel those and plugged 3 in, right? What do you think? All right, y'all take a second and you try number 8. Okay, how did you do on number 8? I'm going to write down what I got. And if you want me to track through it, I will. How'd you do? Did we get it? Yes. I'm not setting you free though. Is that good? All right. So take a couple of minutes. You have a homework in Delta Math, but before you do that, let's see if you can independently go through some on paper. Okay. So if you need to check the key, you can. So I'm stopping this recording.